Okay, so in this is chapter 9. We're going to be working with paired sample. Okay, paired sample simply refers to two sample. In chapter 8, we work with only one sample, right? Only one sample was being compared to a population mean, but here we are going to be using paired sample. In essence, we're going to be working with two sets of data simultaneously and comparing them to one another. Okay, but before then, very quickly, the definition of p-value, right? P-value is the probability of obtaining a test result or a test statistics that is as extreme or as far as the one we actually obtained, if we assume the null hypothesis is true. Very quickly, let's illustrate this. So if I have a simple distribution this way, if the null hypothesis is true, then that null is right in the middle over here. Okay. So let's assume we're thinking about heart rate, for example, before and after an exercise. So or just heart rate generally to make it simple. If I'm thinking about the average heart rates, if there is a claim that heart rate is 120 beats per minute in the population, okay, on the average. So let's assume someone thinks this is that the actual average, the true average is less than that. Okay, so this is just recurring what we learned in chapter 8. So if it is less than that, then this is the claim you're making. You're going to get some data sets, okay, from a number of individuals, to be 30, 40, 50, however many you have access to, or that you determine to get. But of course, we know how to calculate the sample size of the data we need. We had that in chapter 8. You can review that. Okay, so after collecting your data, of course, you compute the sample mean. And with sample mean, as we did in chapter 8, you're going to compute the test statistics. Okay, compute the sample mean, of course, compute the sample standard deviation as well. So using these two, you compute the test statistics. And in chapter 8, the test statistics, the t statistic was, if we're using t, which is often the case because you're dealing with sample data, then we have sample mean minus population mean divided by sample standard deviation over square root of n. So when you compute your test statistics from the data, you're going to locate it along this axis. So let's assume our test statistics fell here. So this is our t-test statistic. Okay. Your p-value is the shaded area from that test statistics to the tail. So this is our p-value. Okay. And what this is simply trying to tell us, this is a shaded portion of the entire shape. The entire shape is 100%. So this would be a small percentage. Okay. And you can go back to the videos on chapter 8 to know how to reject or fail to reject, depending on the size of the p-value compared to alpha. But try to just explain the mean of p-value. So p-value is just the shaded area here, and it's the percentage that is telling us how far, or the chance that we are getting these t-test statistics here, the probability of the chance of getting that. Okay, so if this were to be the true scenario, if 120 beats per minute were to be the true mean, and we're trying to test the claim that it's not, when we gather our data and compute our test statistics, it has, and if truly it's less than that, it could fall anywhere from here, following all these dots, all the way to this point. So the p-value is trying to measure the probability, the proportion, or the percentage chance, right? So better put said as a probability that this test statistics is this far away from the truth, if actually this is the truth, right? So that's why it says at least as extreme as what we have got, assuming the null is true. Okay, all right. So as we walk along, this will begin to make more sense if it doesn't make sense right now. So that is why if the chance that we get this is so small, if the p-value is so small, the chance that we get these test statistics that we actually got is so small, then we're going to reject the null, right? Because you're saying if the chance is like 1% out of 100, or even less than that, 0.05% out of 100, or maybe 0.002% out of 100, then it is rare to occur. So you say that if this was actually true, then it's not possible you would have used the data to get a t-value that is this far off from the true mean. Okay, so that is why we reject when the p-value is small, right? That is why you reject the null hypothesis. Okay, so go back to chapter 8 and watch those videos to get more meaning into this. And we'll try to, bring this back and talk about it as we go along on this chapter. So let's come back to the topic in chapter 9, which is computing the test statistics for paired sample. Okay, so first, let's take note that paired sample is referred to also, let me pick another color here, it's referred to as matched pairs as well. So if I'm doing a paired t-test, I'm doing something as a t-test for matched pairs. Okay, and it's also referred to as two-dependent population. Okay, so it's also seen as t-test for two-dependent population. So these are just different names for the same thing. And why is it two-dependent? Why is it called matched, or why is it called paired? It's simply because you are comparing two sets of data to themselves, but those two sets of data are related. So let's take, for example, as we mentioned before, we're talking about heart beats or heart rate per minute. Okay, so if I decide to assess the impact of exercise on people's heart rate or heartbeat, right? So I could take the heartbeat per minute before, okay, so let's call this one, before the exercise, and I could take another record of heartbeat per minute after the exercise. So let's call this HBPM2, okay? Remember, I'm taking this from the same set of individual, right? So individual 1, individual 2, individual 3. So for each individual, you have a pair of data, right? Before and after. So you have a pair of data for that individual. Because of that, if you're going to assess whether the exercise has impact in changing the heart rate, what you are doing is a pair sample t-test. Okay, that's how this came about. Okay, so, and there are several scenarios in life where you want to do this. And this is the formula for computing the test statistics, right? Remember, you get the test statistics, then you find the p-value, and from the p-value, you can decide to reject or fail to reject. Before we talk a little bit more about that in the next slide, let's look at, explain these items here. I think I should pick up red. I mean, the items on the formula, right? Or the symbols on the formula. N is sample size. We already know that before now, isn't it? So N is the sample size. SD is the standard deviation of the difference. Okay, the difference in the data, right? And that is simply if you subtract everybody's heart rate after from everybody's heart rate before, whatever you get is your and then find the standard deviation. That gives you the standard deviation of that difference. Okay, I'm going to do an example to illustrate that. And then UD is the mean. Okay, let's keep that. Just a moment, I think the system malfunction. Okay, UD is the mean for the difference, the population difference. Right, so if you get the population data and subtract before and after from each other, the mean of that is your UD. And then XD is the sample, is the mean of the sample, of the difference in the sample data, let's put it that way, of the difference in the sample data. Right? So again, if you subtract the data before and after, find the mean of that difference, that is your XD. There is a bar on top of this D. Okay, so we're going to work an example, and this will become more concrete to us. So that's just a notation. But if you look at this, you find out that it has strike resemblance to what we did in chapter 8. Okay, but that is because you are reducing the two sample, you're reducing it to one by finding the difference, right? Okay, we'll explain this more in the next slide. So here, these are the 5 steps to conducting a hypothesis test. And what we're going to do is to get a copy. I want to keep that. Get a copy of this page and maybe make it blank. Okay. Just remove that so we have a blank page and we can work on that. Okay, so let's go ahead and explain each of these slides here, each of these steps here. So the first one is the null hypothesis, right? I mean, the statement of the null and alternative hypothesis. Okay? So let's go over here and write about that a little bit. The null hypothesis, remember now you're comparing two groups. So let's say, for example, heart rate per minute for before the exercise and heart rate per minute after the exercise, right? Okay, so let's say we're using everybody in this class to do that. For each person, that's the serial number. For individual 1, 2, 3, 4, all the way to 25 of us, everybody is going to get a score. Let's assume maybe 120 here, 125 here, maybe 110 here, maybe 109 here, maybe 150 here, and maybe 2. Okay, that's too much. So let's say 100 here, and maybe 89 here, right? Okay, so you're going to have all these different values, and it doesn't, it could go either way. So let me put that one more. Maybe 89, 85 here, and maybe 114 here. So when you're done at the end of the day, you have pairs of data. If you're going to compare these two pairs, so first, this is paired sample, is paired because each person has a pair of data. Heartbeats per minute before the exercise and after the exercise, each person has 2 sets of data, so you have a pair, right? So if you are going to check whether exercise affected the heart rate, you're going to compare the mean. So let's say at the end of the day, you can sum up this. You find the mean for heart rate before the exercise, and you find out the mean for heart rate after the exercise. You're going to compare those two, okay? If the exercise is, so it's expected that the heart rate increases after exercise. So you might be thinking about a null hypothesis that would suggest that mu2 after the exercise, I can put in H here to make it clear, uniform, is the same thing as the mu1, the heart rate before the exercise. Okay, this is one way to state it. Okay, so I'm saying they are equal. In essence, the null hypothesis is saying there is no effect, that the heart rate before and after are the same. Okay, and I deliberately put the heart rate after first, because we expect that to be bigger, and that is because of the next pattern which the hypothesis will be stated. So another way of writing this is to write this as mu heart rate after minus heart rate before is equal to 0. These two statements are equal, right? The first one is saying they are the same. Mu before and after are the same. The second one is saying if they are truly the same, then when you subtract them from each other, you should get 0. Okay, so technically these two statements this and this are saying something in different ways. So there's a third way still, which is the one we actually use in the formula. The heart rate, the difference is equal to 0. So I'm using mu d, right? The difference between the two heart rates is equal to 0. And this is consistent with every other statement here. If heart rate before, after, and before are equal, then when we subtract them, we should get 0. And we are using just mu d as representing the subtraction. We are representing that with just mu d. Okay, so on the homework, the one you're going to be, so these three are equivalent and 3 of them are correct. But on this particular, on the homework, this is the last one is the one we expect you to use because it's more concise, you know. So let's write that by itself. H naught is that mu d is equal to 0. Okay, so if this is your null hypothesis, it's null hypothesis because it's saying there is no effect of the intervention, right? Intervention in this case being an exercise. You could have the alternative states one of 3 things. The alternative could say, okay, well, heart rate after should be bigger than heart rate before, in which case you have H naught, that's mu d, the difference between them should be greater than 0, right? It should be greater than 0, and let me write this in blue. This will be true. Let me use a thicker color so it comes out well. This will be true if mu2, right? Let me use H2 is greater than the heart rate before, which is what is expected, right? If heart rate after is greater than heart rate before, then when you subtract them, the answer you get will be positive and it will be bigger than 0. So let's say, for example, this is 120 after, and this is 80 before. Then you're going to get a positive number, which is greater than 0. That is why you can write the, sorry, this should be 1 here. That is why you write the alternative that way. Okay, H1, right, could be written as this. Okay, remember this is the only way H naught will be written, but H1 can be written like this, and H1 can also be written another way. The alternative could be stated as mu d being less than 0. Okay, in what scenario is this possible? This is possible if, for example, let me pick up blue again. This is possible if, for example, the heart rate after is actually less than heart rate before. Okay, if this is true, then the answer will be less than 0. It will be negative. So for example, if I have, let's say this is 99, and I'm subtracting it from, let's say, before the exercise, it was actually 100. Well, we don't imagine this will happen. You expect that after exercise, the heart rate should increase. But for any reason, if this happens, then the result here is negative, right? -1, really, okay? So that is possible, right? This could be an instrument malfunction or something else, but we're not focusing on that at the moment. So, but we are saying if it happened that the average heart rate before is bigger than the average heart rate after, then you're going to get a negative value. So that is the situation where this other alternative hypothesis become what you see. Then the last one, of course, is that somebody could say, okay, I don't know what the heart rate will be, but I will hypothesize that it will not be the same. The two will not be the same, right? So I'm essentially saying mu1 cannot be equal to mu2. I'm saying this can never happen, will not happen. So in that case, if you are not sure which way, whether it's bigger or less, then your H1 will be stated as mu d not equal to 0. Okay, so just summarizing, these 3 are alternative hypotheses. Let me write that well. Alternative, I think the pen is functioning. Okay, I think I should pick a different color since we've made mistake twice on that. These three are alternative hypotheses. Okay, these three here. So you could use one of them depending on what the person's claim is. So if your claim is that it's bigger, that the difference between them, that mu2 should be bigger than mu1, then you're using the positive one. If you're thinking mu2 should be less than mu1, you're using the second one, the negative one. And then if you don't know, then you're using the difference, okay? And how do you find out which one? You get this from reading through the question. We're going to practice on this, okay? Again, this is just the null. There is only one way to state it. The null we say that the difference is 0, which means the two are equal, okay? But the alternative could take that one is bigger, or the other one is less, or that they are equal. They are not equal. You don't know which way, okay? And so again, this last one is two-tailed. This is two-tailed, right? And these other two here are one-tailed, right? Greater than or less than a one-tailed. Not equal to is your two-tailed test. Okay, so we're going to be repeating this, maybe 2 more classes, and I'm sure it will sink in better, okay? So in summary, I want to keep this. In summary, let me get a new slide and just summarize that. Okay, just write it without the paintings. Okay, so step 1, your null hypothesis could simply be stated as H0, that the difference in the two population mean is equal to 0. That is your null, right? This is saying the exercise has no effect, or the intervention you're considering had no effect. And then, and this is your null hypothesis, right? But for the alternative hypothesis, it could be stated one of 3 ways. So you could hypothesize that the difference is greater than 0, which means, so this will imply that for group 1 or group 2 is greater than what you have the mean of, not group, let's say pair now, the first before, the average heart rate after is bigger than the average heart rate before. So you get a positive result. Or you could write this and hypothesize that the difference is actually less than 0. Okay, so in which case you are hypothesizing that the heart rate after was actually smaller than the heart rate before. Okay, that is when this could happen, or the result will be negative. And then finally, you have that H1, that the mean difference, the mean of the difference is not equal to 0, in which case you are not actually taking any position. You're saying, I know they are not the same. I don't know which one is bigger, which one is smaller, but I know they are not the same. Okay, so why this is your null hypothesis, all these 3 are your alternative hypothesis, right? So why this is saying no effect, the null hypothesis, the alternative is saying there is effect, but now the effect will depend on what the claim is. It could be on the positive or negative side, or it could be that you're testing both sides. And if I should use a color just to emphasize that again, this is two-tailed, right? Why these 2 here are one-tailed. Okay, so I hope that is clear. So this is step 1. That is step 1 that we've just explained. So on your homework, this is the way it will be answered. Again, remember that what you're using is this one here. This is the one that comes into your homework, right? This is the answers that you're expected to give. You're expected to, of course, the null hypothesis will be this way, but you choose one of these as the alternative hypothesis, depending on the nature of the question. Okay, let's move ahead to deal with step 2. So step 2 is talking about determining the type of test. Okay, so generally here, you know that if you don't have, and let me take up a slide to explain that. Maybe we should duplicate this other slide. I want to keep all the markings. So if I duplicate this slide here and make it plain. Okay, so step 2 is determine the test. So remember that we keep repeating this, that when population standard deviation is given, population, when population standard deviation is known, okay, and you know the symbol for that. When this is known, then you're using a Z. If it is not known, okay, so we say otherwise, use a T. Okay, and use a t-test. So in reality, most often we're actually doing t-test most of the time, because hardly do you know the population standard deviation. Okay, so this is our decision. So, and I wanted to emphasize this. If a question writes standard deviation, this is equivalent, or the question is saying what you have is sample standard deviation. Okay, so most question, it seems like making it shorter, but whenever you see just the statement standard deviation, what that implies is sample standard deviation. If it is population standard deviation, the word population will be written in the expression. So if you're reading a question and you see this, interpret it as sample standard deviation. If it's population standard deviation, it will be written clearly as population standard deviation. Right? I'll just use SD to represent that. Okay. To be written as population standard deviation. Okay. Let me write it in full. Population standard deviation. So if you don't see the word, pick a different color to highlight that. If you don't see the word population, then it's not population standard deviation. If it just says, pick a different color. If it just says standard deviation, right? That might not be very clear to those observing this. If it just says standard deviation, then take that to mean sample standard deviation. If it's population standard deviation, then you must see the word population in there in your question, and it should follow standard deviation. You should see the word, the expression population standard deviation for you to use Z. So this is the only condition where you use Z. So if you don't see this word, don't use Z. If you are seeing only this one, it simply means the same as sample standard deviation. So I hope that helps. Okay, so let's move beyond this, and we're going to take a class example, okay, to make this clear, and we'll do that in the next video.